Hi everyone. Today we'll see a few more problems. So if you see the problem statement on DC circuit, DC transient circuits, for the circuit shown in figure, find the current equation when the switch is opened at t is equal to 0. Here switch is opened. Earlier the switch is closed. Now we have to open the switch at t is equal to 0. That means at t is equal to 0 minus the switch is closed only. At t is equal to 0 we are opening the switch. So if you see the circuit diagram, this is 50 volts connected through the switch to the parallel branches, like one is 20 ohms, another one is 20 ohms is connected in series with the 2 Henry. The current flowing through the inductor is I here, this loop. See the solution. At t is equal 0 the switch is open. Earlier t is equal 0 minus the switch is closed. So what we have to do as a first step to find out the current solution, we have to, at t is equal 0, what is happening? Switch is open. At t is equal 0, the switch is open. That's why it is open circuit, the same circuit. Now the remaining circuit, for the remaining circuit you apply the KVL. This is the loop which is having the combination of inductors. This is the loop. So for this loop, if I apply the KVL, 20 into I plus 20 into I plus 2 into di by dt, L into di by dt, voltage across inductance, is equal to 0. There is no source, right? By rewriting this, 40 into I plus 2 into di by dt is equal to 0. If I rewrite the equation again, further simplifying by dividing on both sides with 2, di by dt plus 20 into I is equal to 0. This is your first equation. Non-differential equation is second equation. First step. Second step is non-differential equation, dx by dt plus px is equal to k. Compare these two. Write down that x is equal to I, p is equal to 20, k is equal to 0. For the non-differential equation, what is the solution? X of t is equal to e power minus pt integral k into e power pt into dt plus c into e power minus pt. Substitute all these x, p, k values in this solution, then you will get the I of t solution. I of t is equal to e power minus p is equal to 20 minus 20 into t integral k is equal to 0 into e power plus 20 into t into dt plus c into e power minus 20 into t. So the first term will become 0. Second term we have c into e power minus 20 into t as a current solution. So this is your current solution, but you need to find out this arbitrary constant. For this you have to use the initial conditions. What are the initial conditions? T is equal to 0 minus, 0 and 0 plus. At 0 minus, that means at 0 the switch is open, but 0 minus the switch is closed. So that's what I have written here. At 0 minus the switch is closed. At 0 it is open. 0 plus also in open state only. From 0 onwards the switch is in open state. When the switch is closed, what is the current? We have to find it. When the switch is closed at t is equal to 0 minus, earlier the switch is closed, the circuit is like this. So if you see the circuit diagram, the 50 volt, the same circuit diagram I have drawn here. 50 through the short circuited switch, it is connected to the 20 ohms, and 20 ohms is connected in series with the inductor, right? But inductor will get short circuit in the steady state, because from the minus infinity to 0 minus, from minus infinity to 0 minus, the switch is in steady state. At 0 again we are changing the switch position, right? For longer time the switch is in closed state only. That's why for that longer time the inductor will get short circuit, because in steady state inductor will get short circuit. When inductor is getting short circuit, these two are connected in parallel, and we have voltage divided by equivalent resistance. 50 is divided by 20 connected parallel with 20, so it will become 10. 50 by 10, which is equal to 5 amperes. So again use the current division rule. Total current, you got it, right? So these two are equal resistance. Current will be divided equally into the two resistance. 5 is divided by 2, or 5 into 20, opposite resistance by 20 plus 20, which will get it as 2.5 amperes. So I is equal to 2.5 amperes when the switch is closed for the longer time initially. Even at t is equal to 0, the switch is open. The switch is open. When the switch is open, the inductor will carry the same current. Inductor will carry the same 2.5 current at t is equal 0 and at t is equal 0 plus also, because inductor do not allow the sudden change in current. By using these initial conditions 0 or 0 plus, I will substitute t is equal to 0 plus in the current equation 3. A of 0 plus is equal c into e power minus 20 into 0 plus e power 0, right? E power 0 is equal 1, and this c. What is I of 0 plus? I of 0 plus is equal to 2.5 amperes. So c is equal to 2.5 amperes. I'll substitute the c value in the third equation to get the final solution. I of t is equal to 2.5 into e power minus t. So this is all about the problem.